and welcome, my wonderful learners. I'm happy to be here once again. My name is Mr. Philip Mamman, and usually our series has been Chemistry UTME 2025. Now, if you have questions in any of my previous lessons, you are free to chat me up on my WhatsApp number 080-2659-8861. Again, 080-2659-8861. Today's question is question number 7 on Chemistry UTME 2025. The question is straightforward and it says, the three-dimensional shape of methane is dash dash dash. I know those who have read your book very well already know what the answer is. But I'll need to take you through a series of activities for us to always arrive at the answer. You know why? Because my answers are always evidence-based. It's not a guesswork. So I advise you that when you are answering questions in UTME, you should be sure and know what you're doing. Usually, when you have your questions, first of all, try to answer the one that you are very sure of. Pocket the marks and put them into your pocket. Then you can come and waste time on the questions you are not sure of. Because remember I told you, UTME is about speed and accuracy. And you must also have a residual knowledge of chemistry. And you can get that knowledge only when you study your books. Remember, if you have questions in any aspect of chemistry, you can approach me and I'll be able to discuss that with you. Now let's move ahead to address this question. Now this question is under the concept of hybridization and shapes of molecules. Now let's look at methane. Methane is CH4. Now carbon is the principal element here. So we must write the electronic configuration of carbon. Carbon has atomic number 6. What is the electronic configuration of carbon? It's 1s2, 2s2, and 2p2. This is the electronic configuration of carbon. Now, using hybridization concept, we could put this electronic configuration into a box form, showing you the energy level of each of these shells. Let me use the box form and you see. This is 1s. 1s is the lowest energy level because it is closest to the nucleus. The next one is 2x. Now this is 2x. Why do I have 2x on the same level with 2p? Because they belong to the same energy level. How did I know? 2s, 2p, meaning that they are on the second energy level. It's just like a story building. The first floor is the lowest in energy. You can climb it with ease. The second floor, you need more energy to get there. So that's how these electrons are arranged. Now, these 2p have 3 subshells, or we call them degenerate orbitals. We call them what? Degenerate orbitals. Because the shape of p is like a dumbbell. Let me show you what I'm talking about. This is the shape of p. The dumbbell is something like this. And something like this. Then we have the z-axis, something like this. When you say something is three-dimensional, it means it has 3 axes. The x-axis, the y-axis, and the z-axis. And you can see this in cubes. For instance, this building. When you look at the length here, it's called the x-axis. Then across like that is called the y-axis. Then from up to down is called a z-axis. That's why it's a 3-dimensional figure. Hello? Let me come again. A 3-dimensional figure has 3 axes. The s, the y, and the p. So also we have 1, 2, 3. This is 2px, 2py, and 2pz. Now let's fill in each of the electrons. Now we are going to fill in each of these electrons observing our quantum numbers. Wow, it's strange, right? You've never heard that word before. We have what we call quantum numbers in chemistry. And there are 4. We have the principal quantum number, the azimuthal quantum number, the magnetic quantum number, and the spin quantum number. I will take it again. The first one is called principal quantum number. The second one is called azimuthal or subsidiary quantum number. The third one is called magnetic quantum number. And the last one is called spin quantum number. In my subsequent lesson, when I come across a question that has to do with this quantum number, I will explain them to you in details. But what I'm more interested in is spin quantum number. Each of these electrons have a different spin, such that 1s2, the first electron spin clockwise, the second one spin anti-clockwise, and this is what the arrow is showing. So you see the two electrons are spinning in different directions. Then we come to 2sp, 2s2. We have 1 and 2. Now, when we are going to fill the 2p, we are going to obey a rule called Hund's rule of maximum multiplicity. Wow, it's a new word, right? Let me take it again. Hund's rule of maximum multiplicity. Hund is spelled Hunds. Hund's rule of maximum multiplicity. What it states is that electrons should enter into the degenerate orbital singly before pairing. So it means that if you have two electrons here, you cannot put the 2 in px. No, you have to put them singly. If there is more, then you can now start pairing. Obeying that rule, it means in 2p, we have 1 electron in 2p1, then we have 1 electron in 2py, 1 electron in 2px, and 1 electron in 2py, meaning that 2pz is empty. When this happens in chemistry, we call this ground state. And ground state means when an element is at its lowest energy level. Now, this element can absorb energy and become excited. Hello? An excited state is an event where an element absorbs energy and an electron in the same energy level is promoted from a lower energy level to a higher energy level. I will explain that to you. Now, let me draw this box again. You have your 1s here. Now, this innermost shell is not tampered with. We deal with the valence shell, which is the outermost shell. Then we have our 2s, we have our 2px, we have our 2py, and we have our 2pz. At excited states, when this carbon atom have absorbed energy,